Well, I'm extremely excited about today. This is, of course, day 4 of week 2, and we're getting on to our first large, juicy project in the form of deep research. This is one of the classic use cases of agentic AI, the case where you have an agent that is able to go off, search the internet, and do some research, look at different links, and try and research a topic that you give it. And we know this so well because many of the frontier labs offer this agent via their online chat tools. And for example, on OpenAI, you can go to GPT and you can press the deep research button, and that runs a model in deep research mode, which is basically running an agentic workflow. So we are going to do that. We are going to give our agents the ability to do deep research. And we're going to use a few things that we've already learned about. We're going to use tools, of course. We're going to use structured outputs again. We encountered it briefly last time, a little bit more this time. And we're going to use something called hosted tools for the first time, using tools that are running remotely. All right, let's get straight to it. Okay, so here we are in Cursor. We're going to open up the directory for week 2, and we're now going to lab 4, deep research. And we are going to start again in a notebook like this, in one of the notebooks running within Cursor. And I know that a lot of you would prefer to be working with real Python modules, and fear not, we will get to that tomorrow. We will do this in Python code and proper modules. The lab, this kind of format, these notebooks, they're so good for talking through things, for experimenting, and it gives you the power to be changing things, playing around while we go through this. So I think it's good just for today. So this is, of course, an enormous classic agentic use case. And what's great about it is it applies so broadly. You can apply this to any business area. You can build a deep research agent that's focused on your business area. Or you can use this as something which is like a sidekick for yourself. We're going to build a different kind of sidekick later in this course, but this is one kind already, and it should be useful for you immediately. So I think it's terrific that we're doing this, and I hope you're as excited as me to be building your own deep research agent, something which the Frontier Labs have done themselves. Okay, so let's get started. Enough of my prattling away. We do some imports. We do one of these usual load.envs. All right, and now it's time for me to talk about the big change this week, which is that we are going to use some things called hosted tools, which means that they are tools that OpenAI is going to run for us. There only are 3 of them that OpenAI provides, at least as of now, and we're going to use one of them. The 3 are the web search tool, the file search tool, and the computer tool. The web search tool lets us do what we're going to do today, which is ask OpenAI to run a search on our behalf. The file search tool is how we can run searches across the vector stores that you can upload and have remotely with OpenAI. And computer tool allows things like taking screenshots and clicking around a computer. Now, we're not going to be using either of those two. We're going to be doing the web search tool, but fear not, later in the course, we will have basically our own computer tool, but we won't be running it hosted. We'll be running it on our own computers, as you will see, in case that sounds intriguing. But for now, we're going to be using the web search tool. And I want to make an important point, which is that OpenAI's web search tool is not that cheap. For some reason, which seems not entirely clear to me, it actually costs 2.5 cents right now for me to run this for even at the low end of the cheapest model at the lowest end. 2.5 cents per call, which may not sound like it's a huge amount, but typically if we're running a deep research, we might be doing like 10 different searches. And that means it's 25 cents a pop, which means that you can quite quickly add up to $2 to $3, which is what I spent the first time I did this. I think the way I have it set up now would be more like $1. Still, that's maybe not to be sniffed at. So I would suggest monitor this, and you can decide to skip doing the searches, or I'll show you where you can tone it all the way down so that you're only spending a few cents. And then later in future weeks, we're going to be doing this a bit differently, and we'll have other ways to do this, which will cost a fraction of this. So fear not. But for now, it's nice for us to use OpenAI's, and OpenAI's is actually really good. So maybe it's worth the 2.5 cents. I don't know. The costs themselves are on this link here, so it's always worth double checking because it might be different for your region, or OpenAI might change the pricing all the time. So go there and you can look. We are going to be using GPT-4o Mini Low Search. Okay, with that, let's get started with our first search. Okay, it's now time for us to create our first agent for this product. And the first agent is called the search agent. So here are the instructions, the system prompt for this agent. You are a research assistant given a search term. You search the web for that term. You produce a concise summary, 2 to 3 paragraphs, capture the main points, write succinctly, and no need to have good grammar because it will be consumed by someone else synthesizing a report. It's a very clearly written set of instructions right here, and I would love to take credit for it, but I must confess that I just took this verbatim from OpenAI's documentation for how to do web searches with their tool, so we could probably take it on good authority that this is a well-written prompt, since it's written by the people that built the model. So we're going to use this prompt. We're going to create a search agent. It is an agent named search agent. This is the instructions. And we're going to give it one tool, and that tool is called a web search tool. And this is one of OpenAI's 3 hosted tools. So we're providing that as our tool. There is an optional parameter. You can specify the search context size, which can be low, medium, or high, where that reflects the price that you'll pay. Low is, of course, the cheapest. And then medium is the default, is only a little bit more, but high, I think, is quite a lot more. You can also pick the model. It's a lot cheaper to pick GPT-4o Mini. GPT-4o is a lot more. And finally, there's this here. This is a nice little snippet of code to keep in mind. This is how you say that this agent is required to run the tool. It is mandatory. It doesn't have discretion over this. So this is the way you do it. You pass in this model settings with tool choices required, and that's a nice handy thing to have to one side. And of course, in this case, we want to do that. It's basically this agent is wrapping this tool call. And so when we're picking GPT-4o Mini and we're picking low, this is when, as of now, this costs 2.5 cents every time we run this agent. So let's run this agent. Let's ask for the latest AI agent frameworks in 2025. We will run that search and we will display the results and see what happens. It's running. And there we go. There are the results. It's come in nice markdown. Let's see. It says LangChain, LangGraph, Crew, Semantic Kernel, AutoGen, OpenAI Gym. That's not exactly. I get that's a reinforcement learning framework. It doesn't know about itself. It doesn't know about OpenAI Agents SDK. Amusingly, Rasa is an older framework, and Jade for Java people. And so an interesting set of results. I'd say mixed accuracy, because I would argue that LangChain and Semantic Kernel aren't really agent frameworks, but certainly LangGraph, Crew, and AutoGen are very much there, and ones that we will be spending a week on each. All right, but this is a perfectly pleasant search result, and it is the beginning of our deep research agent. And it's always worth taking a quick look at the trace in OpenAI. So click on this little useful link here, and up it comes. And here it is. The search agent is our current trace. If I open it up, we'll see, sure enough, that the search agent was called, and it tells us over here the tool it used was web search, and we get a bit of information about the total number of tokens that it did. That's the instructions, the system prompt. That was the user prompt. And this comes back is the output, just as we would expect. The trace has worked nicely. Now we can get on with the show. Okay, so now we're going to work on another agent, and we're going to make heavier use of structured outputs than we did last time. So the agent in particular that we're going to work on, we're going to call the planner agent. This is the one that's going to be responsible for taking a query and coming up with a handful of searches that it should run based on that query in order to do some deep research. Now, I'm going to keep the number of searches small to 3 searches because, as I say, it's 2.5 cents for each search, and I don't want to add up to some big old bill. When I first did this, I had that at 10, so you certainly can have it at bigger numbers. You obviously get better results if you do that, and it's very much a personal preference thing. Run it with 3 to start with. See, you'll cost 10 cents, 20 cents, and if you're enjoying yourself, then, splash out, spend $50. And get one really good comprehensive result. Okay, so we're going to keep it on 3. So the instructions, what is the system prompt we're going to use here? You're a helpful research assistant given a query, come up with a set of web searches to perform to best answer that query. Output, and then, the number 3, terms to query for. So that hopefully is super simple. We're just building an agent that is going to, given some sort of a query, come up with a bunch of things you would search the internet for in order to research that query. And we're calling that the planner. So keep that in mind, because then everything is going to click into place. So now we use structured outputs. Remember this. This is where you have a class that is a subclass of this thing called base model from Pydantic. And that means that we're going to use it as like a schema. We're going to use it to describe a structure, which we will later ask a model to return information in. And we in the case of a web search item, we're going to have a reason and a query. And the reason is a string and the query is a string. And the doc string that we have right here underneath, this is super important. And by adding this documentation, by annotating these fields with this comment right underneath them, we ensure that information is actually provided. That's as part of structured outputs. That is part of the information that's provided to the model, so it knows why it's populating these fields. So this is another good trick. We didn't do that yesterday, so now you've got this in your toolkit as well. Now, one other small point. There's various reasons why you might ask for a reason as well as just the query. But one of them is that this does actually result in sort of reasoning style behavior. This is very similar to what people call chain of thought prompting. I guess it is chain of thought prompting. But by asking the model to output its rationale for why that search is important, and actually by asking for that first before the query itself, you encourage the model to be sort of apparently thinking through. And as a result, you tend to get better outputs. You get better queries just as a side effect of asking for a rationale first. And I've said it before, but you always have to come back to remembering that while we try and treat models like there's a bit of humanity to them, this is just a strange side effect of great next token prediction. Because it's predicting the most likely next tokens, that's all these models are doing. If you ask it to start predicting tokens reflecting a reason, then when it starts to predict tokens reflecting the query, it is more likely to be consistent with that reason. And it ends up with this very coherent output that just makes more sense, that has a higher likelihood of being what you're after. So those little sidebars, and I do have a bunch of YouTube videos that clarify that more, but it's so important to keep that in your mind because it really helps figure out what works well with these kinds of prompts. All right, so this is a Pydantic object with a reason and a query. And now we've got another one called web search plan. So this was web search item. A web search plan is a list of web search items in a field searches. So this is an object which has one field, searches, and that is a list of these guys. And you can see it says there, a list of web searches to perform to best answer the query. A list of web searches to perform to best answer the query. And that is what goes there. And this annotation is associated with this field searches. Okay, hopefully you are with me. So then we now create our planner agent. It is an agent that's named Planner Agent. Its instructions are these ones right here. The model is GPT-4o Mini, and the output type. Remember, this is where we specify structured outputs. We tell the Planner Agent that it shouldn't output in text like these things normally do. It shouldn't just generate natural language in the form of text, but rather it should build an object of type web search plan, which means it's an object with one field, searches, which has a list of items that looks like this. And remember, as another sidebar, keep in the back of your mind, when I say that we're going to tell the model to create an object, maybe that all sounds a bit magical. Like how does a large language model, a transformer architecture, know to generate objects, Python objects? Remember, anytime you hear magical stuff like that, it usually means we're talking about JSON behind the scenes. And that's exactly what this is. What happens is that this is turned into a bunch of JSON and the model is prompted and it says your response should conform to this JSON. Here is how it needs to look. And as a result, the model generates that JSON and it gets populated into an object of this type. That's the end of it. There's nothing magical about it. All right. We should now run this and see it working. Here we go. Let's do it. We run this, and now we're going to say the same thing that before we just did an internet search on latest AI frameworks in 2025. What we're now going to do is carry out, we're not going to do any searching at all. We're just going to use this planner agent to come up with 3 web searches that would be relevant, and we want it to respond with an object of type web search plan. So let's see what we get if we run it and print the result. So what we get back is an object which has a field searches like that. And that field is a list. Good. And it's a list of things called web search items. Great. And a web search item should have a reason and a query. Reason, to find the most recent developments and releases in AI agent frameworks for 2025. And the query is just latest AI agent frameworks 2025. Okay, fine. That doesn't seem particularly profound, but it seems perfectly reasonable. The next one, to explore industry specific or academic research. And the query is emerging AI agent frameworks. And the next one is to be updated with major conferences, publications, or announcements. AI frameworks, conferences, announcements 2025. Fair enough. Seems like a perfectly plausible, reasonable way of doing it. I'm not sure I would have done that last one, but who's to say whether I would have done it better or GPT-4o Mini is going to do it better. But that is the planner at work, and you're seeing structured outputs used very well there. Okay. Next one is a boring one because you know it well. I've brought in the same send email tool that we used before. So we're using the decorator, the function tool. If you remember, you use that decorator if you want to convert a function into something that can be a tool, and it will generate all of that JSON gumph for you behind the scenes. So this is send email, a subject and a body, and it sends out an email with the given subject and the body. We're going to use send grid as before. Hopefully you still have your account handy and you have it in your .env file. Remember to change this email. Let me change this to your verified email. And yes, and please do also change this one again. Don't send me lots of emails with AI generated content, but by all means send me emails with your questions. Of course, I always welcome them, but I don't welcome AI generated deep research things as much. So then content would be the HTML version, and then we send the email exactly as before. That is our tool. You don't need to see this, but I'm going to show it to you anyway. You remember that if I just print this, what's it doing here? If I just print this out, we should see that we get a function tool with a description and so on. And if you're not sure why this has happened, then do look up decorators. Make sure you understand how decorators work and how they're able to convert a function like this. Okay, with that in mind, this is an email agent. This is all old hat to you now. We've done this several times. The instructions are you're able to send a nicely formatted HTML email based on a detailed report. You'll be provided with a detailed report. You should use your tool to send one email, providing the report converted into a clean, well-presented HTML with an appropriate subject line. So you can see I'm no longer trying to break things out. I'm giving this agent full discretion to come up with a subject line, to rewrite the email, to do the whole lot using GPT-4o Mini, and we're providing it with the one tool to actually send the email. So that is our email agent, and that is something which is old news to you. You know it super well. Okay, we're about to get real, and so I will take a pause for a second, and then we will get into the real meat of the project. Okay, so we have another agent again that's going to use structured outputs. So this is the researcher. So you are a senior researcher tasked with writing a cohesive report for a query. You'll be provided with the original query. and some initial research done by a research assistant. You come up with an outline for the report that describes the structure and flow of the report, and then generate the report and return that as your final output. It should be in Markdown. It should be lengthy, detailed, 5 to 10 pages of content of at least 1,000 words. Okay, so that has framed the situation. Now we're going to use structured outputs again. We're going to have a report data Pydantic object, a subclass of base model. It has a short summary, which we begin with, a short 2 to 3 sentence summary, the full markdown final report, and then some follow-up suggestions, suggested topics to research further. And so this is an agent. It will take these instructions. It will use GPT-4o Mini. The output type, this is where you specify that we're using structured outputs. The output type is the report data. And there we have our report writer and this our writer agent. And this is the final building block before we get to the actual flow through this project. Okay, so it's crunch time. We have 5 functions for me to show you, but they're relatively simple. They're pretty straightforward. So here they are. I'm going to show you the 3 and then 2. The first 3, the ones that are going to execute a search using the 2 agents that we defined before, the planner agent and the search agent. And these functions, you can see they're very short, they're very simple. Let me tell you what they each do. Plan searches. All right, this very simply calls runner.run for our planner agent passing in the query. And we make a query and that gets passed into the planner agent. Remember, the planner agent is the one that will then come back with a number of searches. So we'll then count how many searches there are and print that, and we will return that final output, which is in the form of that search list. It's what form is it again? It is this thing here, the web search plan, a list of web search items. All right, back we go. Okay, so then the next function is perform searches. This is when we're actually going to do the searches for each of these. Now, do you remember I showed you that asyncio.gather a while ago? That was the great way that you can run things in parallel. Perfect time for it right now. So we're going to create a bunch of asyncio tasks to search for each item, in the results of the searches. This is the Pydantic object. That searches field gives you the list of the search items. And for each item, we were going to call search. Search is the next function we'll talk about. We're going to call search. This gives you a coroutine, so we can turn that into a task. And then we can use this gather approach that I told you about, asyncio.gather. If you then await that, it will run all of these tasks in parallel, and the results will go into results. And then we will put finished. So hopefully I didn't lose you there. Basically, all I'm saying is we take the results from the planner and we just search for all of these things in parallel using the search agent. And this is how we actually use the search agent. We give it an input. What we're actually doing is we don't just tell it the query, we also tell it the reason that we're searching for that. You remember I said there's more than one reason why we ask for a reason. It's also so we can give some context here. And then we run the search agent, and then we return the final output of the search. Okay, hopefully you followed these 3. If not, come back and look at these as such short functions that it should make sense. And then finally, some housekeeping, 2 functions, one of them to write the report, one of them to send the email. The writing the report will use a writer agent. It will run that agent that is going to reconstitute the output in HTML. And then finally, we will write an email using the email agent. And that will then complete the process. So I should run these 2 to define these 2 functions, these 5 functions. And now we should be ready for showtime. All right, and if you're one of the people that doesn't like the way that I just execute code and talk to it, that's sort of lazy, then you're going to be happy. This time I will type the code so that we get to do this part together. So it is our moment of truth. We're going to say, like, with trace, research trace. Cursor's already filling it in. I'm not, no luck for me. Well, I'm going to ignore what Cursor's saying here. I'm not looking at that. So we're going to print a message like starting research. Sometimes Cursor is too good. All right, let's get rid of Cursor. No cheating. I'm not looking at what Cursor's saying. Search. What if I type something different? Confuse Cursor. All right, now search. No, it doesn't work. It still figures it out. All right, but there we go. It knows. So the first thing we're going to do is have a variable called search plan, which is going to await planning the searches. So if you come up here, there is planning the searches. So that's the first step. We do that. All right, the next step is the search results. We're going to perform the searches. So we come up here, we perform the searches, passing in the search plan. That's the next step of this, which we also await. The next thing we need to do is actually run the report. So we await writing the report, passing in the query and the search results. And Cursor knows well, as do you. You're already saying what we need to do next is send the email. And that really is it. I can take out the, and then I can print. All right, we'll do something different to what Cursor suggests to show that we have some autonomy here. We're not just ruled by the machines. Okay, there we go. Let's kick this off. Let's have this running. So it's starting the research. It's planning the searches. It will perform 3 searches. So it's, and it's already finished. So it used an agent to figure out what 3 searches to do. And then for each of those, it used a remote, a hosted tool from OpenAI to actually carry out that search. It got back all of the results. We're now using an agent to synthesize the results and turn it into a report using, it's going to generate a report in Markdown, and then it's going to turn that into an HTML email. So we will let it do its thing. Let's just come back up. The final report is in this format, which has Markdown as one of the parts of it. And that's the part we're now doing the writing email, and it's in writing the email that it will both come up with a subject line, and it will also write it as an HTML email. And in a second, hopefully I will receive that email. Okay, it did indeed finish. It completed its 3 searches. It ended with hooray, which is success. And I received an email, and here it is, a nice HTML email, well formatted with a good introduction, an overview, detailed analysis crew. It's now putting at the top, which is in fact what we'll be doing next week. Look forward to that. And then there's generally some great information here. I would say that there's a couple of misses, but it's generally done pretty well. And then at the bottom are some references with links, since it's an HTML email. And if I click on that, it does appear to work, which is nice. And I will say I do find it very satisfying that with this minimal scaffolding, with something that was really very simple indeed, there's not much code to this. Look, that's all there is. With just this, we were able to build this whole deep research framework. And whilst, maybe those results are reasonably simplistic, I hope you appreciate how much potential there is with what we've just built and can think of all the different ways that we could expand on this. And in fact, one very simple way we can expand on this is just to turn up that number, which you may not want to do because, as I say, it will cost that few cents a piece, but there's no reason why I can't do it for you so that we can get to show you what it looks like to have that deeper kind of research. So I will do that right now. We will change that to 20 and go through and make sure that we, hang on, if I just set that properly. Yes, I have. That has now recreated that planner agent. So now we will come back down here and just make sure that we rerun everything and rerun this. And now we will expect to do rather a lot more searches, 20 more searches. And this may take a moment longer, and then I will come back and show you what results we get. And that is completed after 20 searches, and I can show you the results, which actually, it looks generally a bit similar. It's got the same key frameworks, but it's got more information laid around it. It has applications and benefits associated with each of the frameworks that I identified. And then it has some commercial implications at the end and a conclusion. And so it's certainly more substantive than the previous one. It's a step up. And obviously, should you wish, I would very much recommend that you experiment with this. And we should also, of course, go in and look at our trace. And if we come in to the research trace, we will see that all of these agents ran, and they all ran in parallel. The planner agent took that time to start with. Then there's load more. There's all of this and more. And then at the end was the writer agent and the email agent. So you can see everything, and it definitely gives you that sense of how Async.io ran all of these different searches in parallel at the same time. And then, of course, the writer and email were sequential. And that then is the conclusion of this part of the deep research agent. The thing I'd like you to do is bear in mind, have a think about how you could make this more substantive. What more could be done? What would you like to do to beef this up? And then we'll do our quick wrap up before we launch into tomorrow. So I really hope you enjoyed that as much as I did, and that you appreciate how simple it was to build that framework around a deep research agent, and that you're deeply puzzling over how you can make it better. But actually what we're going to be spending tomorrow doing is putting this into an application and having it be something that is like a takeaway deep research agent. And I'm very excited for it, and I will see you then.